Welcome everybody to the education series here at the Electric Education Center. This is session number 3, and the subject matter for today is arc fault circuit interrupters, AFCI protection. Before we dig into it, before we get started, I want you to get a piece of paper and write down these two types of AFCI devices. Number one is a combination type arc fault circuit breaker, and the other one is dual purpose type circuit breaker. Two different products, okay? The combination type is an AFCI that detects both types of arcs. It'll detect line-to-line and line-to-ground arcs, as well as inline arcs. So that's why it's called the combination type. That's the type of breaker that's required to be installed today. If you're putting in an arc fault circuit breaker, it's got to say right on it, combination type. The dual purpose type circuit breaker, or receptacle, is one that provides both the AFCI and GFCI protection in one unit. The AFCI part of it has to be the combination type, and the GFCI protection I covered in session 2 of this series. The dual purpose breaker or receptacle has to signal which type of protection it was that tripped out the unit for purposes of troubleshooting. So the two different products are combination type versus dual purpose type. All right, the AFCI, the arc fault circuit interrupters, it was designed to detect an arcing event and interrupt the current flowing in the circuit before a flame can be ignited or a fire can start. AFCI protection is an equipment and a property protection, as opposed to GFCI, which is the ground fault circuit interrupter, which is more of a people protector. Will an AFCI device detect an imbalance between the hot and neutral conductors just like GFCI would? Not necessarily. First of all, an AFCI is normally not considered a Class A device. Class A device is one that's designed to trip when it senses 5 milliamps difference in current between what's going out and what's returning from the circuit. 5 milliamps plus or minus 1. So a lot of times you'll see them rated between 4 and 6 milliamps. The AFCI does sense an imbalance, but it's at a much higher value like 20, 30, or even 50 milliamps. Remember that 5 milliamps is 0.005 amps, and that is supposed to be the level of current below which it would not cause defibrillation of the heart. New product development, you know, when AFCI was just being brought out as a product and all that, they had to work out some bugs, as with any new invention. You have to work out the bugs and keep improving the design. Look how long it took automobiles before they were required to be fitted with seat belts. Follow that improvement with the invention of airbag technology protection. Look how long it took for that. Well, the AFCI is no different. The industry is constantly working to make this product better. For lack of better terms, there are two types of arc paths, parallel and series. The first generation of AFCI breakers only sensed the line-to-line or line-to-ground faults, known also as a parallel arc, and it was plagued by what some people would call nuisance tripping. I called it just doing its job. Then it was discovered that you could also have an inline or a series arc event, like the one that happens when you operate a toggle switch for a light. The parallel arc would be an unfriendly arc. The series arc like that from a light switch would be labeled as a friendly arc, or something that we expect. However, there is an unfriendly series arc also, such as the one created by a loose or a burnt connection on one or two of the screws on the side of a duplex receptacle, or a loose overheated wire nut termination, or the loose sloppy fit of a plug blade into a duplex receptacle. So that's the type of faults you could have. Let's move on to the second generation of arc fault protection. The second generation of the AFCI is what's known as the combination type, and it contains enough programming to distinguish between friendly versus unfriendly arcs. With that being said, there's still cases of what people would call nuisance tripping happening with the AFCI protection. I've heard stories of garage door openers, various types of luminaires, both fluorescent and LED, and even brand new appliances, all causing nuisance tripping of AFCI protective devices. So in any case, the AFCI type circuit breaker that you install from this day forward must be the combination type until you hear different. Okay, this combination type, says it right on here next to the handle, combination type. And this also has the two different ways to tell you, there's two different lights that would light up that would tell you which type of protection this breaker tripped on, whether it was GFCI or AFCI. And we need that so that we can do our troubleshooting. Now, I recommend that any electricians and any electrical inspectors, the buildings that you're in, if you run into these first generation of arc fault circuit breakers that are not combination type, I recommend that they be replaced. All right, so how does an arc fault develop? Well, arcs begin as a result of tool cord or extension cord or lamp cord that's been physically damaged and it's been stressed to the point where the insulation or the sheathing has broken down. An extension cord constantly stressed at the same point will eventually develop a break in the insulation. I have one here that I could show you. And at this end of the cord, for example, you can see where the sheathing is already broken, and then the conductors in there are next. Well, at the other end of this cord, okay, it already has frayed enough, and you can see the copper conductors already coming out of the inside insulation. All right, so that's the type of thing that happens to these stressed cords. So now we have the path for an arc to develop. The electric current's going to take a shorter path, which it will always do to get home where it came from. Then it creates a hot spot. And then 5 or 10 amps starts to fight across this poor connection. And you might say, yeah, Rich, but won't the 15 amp circuit breaker trip at that point? No. Listen to yourself. No, 5 amps or 10 amps of a high resistance short circuit is not going to trip a 15 amp breaker. 10 amps is just not enough to do it. Hence the need for arc fault circuit interrupters, because we want to trip the breaker before the arc has a chance to ignite a fire. What are some of the causes for these arc faults in the first place? Well, we could have a Romex staple driven through a cable during the rough-in phase for wiring up a house. We could have a nail from the siding installer piercing the insulation. We could have a nail or a screw driven into a wall by the homeowner. All these can cause electric current to arc to some unintended surface. A quick story about a deadly fire in a Philadelphia row home. This family bought a space heater of some type to heat up the bedroom during the wintertime, and the bedroom was shared by a grandfather and his 8-year-old grandson. So the new appliance was plugged into an old sloppy fitting receptacle. You know, the type where you plug something in and the plug just about falls out of the wall there. So they had the new appliance plugged into that old receptacle, and then while they were sleeping, the connection overheated. An arc developed and ignited the wall, and the fire grew very quickly, and the grandfather was burned very badly, but the grandfather survived the fire. The third grader did not. So an AFCI receptacle device or circuit breaker, in this case, would have most likely prevented that fire from starting in the first place. Talking about that sloppy receptacle, I mentioned this tension checker in the last session that I gave, and I'm just going to mention it again. But this is a wood head tension checker. Okay, you set the indicators to 0 there, and then when you pull it out of the wall, it'll tell you the tension, how much tension was on there, and they give you parameters that come with the tester. They'll tell you what readings to look for, and they have the ground pin also. So I'm going to talk about that more in the next session, which is receptacles. So, but for this session here, the AFCI information you need is going to be found in the National Electrical Code in section 210.12, 210.12. And in section 210.12a, the places are listed where the AFCI protection is required. Now, in a house, in a dwelling unit, basically it's every room except the bathroom, the garage, and an unfinished basement. AFCI is also required in commercial buildings in guest suites and guest rooms of hotels and motels, as well as sleeping rooms of nursing homes. So there are 6 possible methods listed in the NEC for providing this AFCI protection. All right, I'm into the middle 8 minutes now, and I have a couple questions from last week's GFCI production. Guy wrote in, Rich, a customer of mine bought a brand new refrigerator and plugged it in their garage. The new refrigerator tripped the GFCI. The replacement GFCI receptacle I installed also tripped. I put in a third GFCI receptacle and that also tripped. And at this point, I told the customer to send the refrigerator back to the store and have them send a new one. So they did that, and the new refrigerator still trips the GFCI receptacle in the garage. He wants to know if I have any ideas. He also said, by the way, I read the manufacturer's instruction book, and they recommended not putting the refrigerator on GFCI protection. Imagine that. So they're telling you that their product has more than 5 milliamps leakage current. So here is my recommendation. Buy a refrigerator that was made to American standards and that will work on GFCI. That's my recommendation. Another contractor called me up with a similar complaint about one of those Peloton bike rides. And that also trips the GFCI receptacle that he had installed in the basement for this ride. So it seems to me that both products were foreign made, and maybe that's a clue to the problem. Okay, maybe we have to stick to buying things that are made to American standards. Maybe not made in America, but at least made to the American standards. So that's the best answer I could give you on last week's questions. Getting back to how we provide arc fault protection, there are 6 methods I said listed in the NEC. Method number 1 is the most common for new construction. You simply install a combination type AFCI circuit breaker installed in the circuit breaker panel, and that provides protection for the entire branch circuit. Just one important point here. Don't forget that combination type is different from the dual purpose type. Combination type is the type required to be installed today. A dual purpose type provides both AFCI and GFCI protection in one breaker. They're 2 different products. And we'll get to the dual purpose in a minute. Method 4 of the 6 methods in the NEC is another one worth talking about. It's simply installing an outlet branch circuit receptacle type in the first receptacle on the circuit, as long as the branch circuit conductors are continuous from the overcurrent device, the fuse or the circuit breaker panel, continuous from the overcurrent device to the first receptacle on that circuit, and it does not exceed 50 feet for 14 gauge conductors or 70 feet for 12 gauge conductors. Also, the combination of the breaker and the receptacle device have to be listed as a unit to provide system combination device protection. So Eaton makes such a product. You might be able to see this poster behind me is an Eaton breaker replacement chart. Eaton is spelled E-A-T-O-N. Method 5 can be used when you have a fuse panel or maybe a circuit breaker panel in the basement of the home or in the garage of the home that does not have an AFCI model breaker available. In this situation, the code allows receptacle outlet, and that can protect the whole circuit, but it has certain requirements. With this method here of using this receptacle, you can forget any AFCI breaker and just install this receptacle in the first outlet box as long as there's a metallic raceway to said first box. So an electrician said to me, he said, Rich, how am I supposed to run EMT conduit to the first receptacle on that circuit up on the second floor of a house, like the code tells me to? Well, you're not thinking. First of all, the reason for the metallic raceway, like EMT or a piece of MC cable, is that it assures that if someone were to drive a screw or a staple into this connection, we would find out right away because the AFCI device would trip or the main overcurrent protection would trip as soon as that circuit is energized. If the code allowed you to just rely on the existing non-metallic sheath cable, well, it's possible to drive a screw or a nail through the Romex and not find out for years later. And then it starts to arc, and that's when the fire starts. The location in the circuit will ensure that the branch circuit, entire branch circuit, is protected. So, how do you handle that? Well, you don't run EMT up to the second floor receptacle circuit for the bedroom. So, what you do is you just install a new AFCI receptacle box right next to the circuit breaker panel or the fuse panel, and then just take that branch circuit out and feed it into the junction box, the device box, and then you're going to install this, and you're just going to run a new home run from that box 2 feet or 3 feet back, right back into the panel, and connect that circuit where it always was connected in the first place. Okay, so that's how you handle that. And the code recognizes this receptacle as being able to provide all that protection, as long as it's a metallic raceway up to this particular box. So there's, like I said, there's 6 methods, but those are the 3 most popular. Let's talk about 4 common types of arc fault circuit interrupter devices. First, you have the combination type AFCI circuit breaker, which senses the inline and line-to-line arcs. Okay, and you have then the dual-purpose AFCI GFCI circuit breaker that provides both types of protection. You would use this for kitchen countertop receptacles, for example. The kitchen countertop receptacles now, with the 2020 NEC, need arc fault as well as GFCI protection. So if you install this breaker, this is Siemens breaker. If you install this Siemens breaker in there, you could see that it has 2 pilot lights on there, 2 indicator lights here, and one is for arc fault and one is for ground fault. So when this trips out, it will tell you what kind of protection it tripped out on. And then, of course, you have your test button here, which you are supposed to test these devices monthly. And we get no relief from that, even though the circuit breakers will analyze their own circuitry every 5 or 10 seconds. Does not matter. We still have to test the units, the breakers, and the receptacles, monthly. And what we're doing there is we're testing the mechanical operation of the whole thing. You know, I'm going to talk about overcurrent protection in a future series, but I mean, you know, you're expecting a circuit breaker you bought for $3.50 that was made not in the United States. Okay, it was made in another country, and you're going to put this breaker in somebody's circuit breaker panel, and you're going to expect that breaker to sit there in that panel for 10, 20, 30, 40 years. And then when there's a short circuit, you're expecting that thing to work just fine. That's an amazing requirement for something that costs $3.50. But that's how good our industry is. So you have the combination type circuit breaker. You have the dual purpose that you would use for the kitchen counter receptacles, for example. Then you have the receptacle outlet type. They come with this protective band on here to remind you that you're supposed to be hooking up your hot side to these terminals up here. And if you wire it line and load, line up here and put the loads down here, it will protect everything downstream. If you pigtail your 2 hots and your 2 neutrals and just connect to the top 2 terminals on the line side, then you're only protecting what is plugged into this particular receptacle. The 4th type is integral to the cord, and you'll see it when you see window air conditioners. All right, window air conditioners come with a device built right into the cord within 12 inches of the plug itself, and sometimes they're just called the LCDIs, leakage current detector interrupter. But that is the fourth type of arc fault circuit interruption that you could have. What kind of circuit breakers are sold? Well, I just want to show you this one here. I mean, take a look at the circuitry that's in there, and that's how complicated these AFCI and GFCI circuit breakers are. I mean, that's an amazing invention to fit into such a small package, and we expect it to do all that it's doing and to save lives. It's amazing. But what kind of circuit breakers are sold? Well, you have a single pole arc fault circuit breaker, and then you have a single pole dual purpose, both AFCI and GFCI. Then you also have two pole circuit breakers that are straight AFCI, or a two pole AFCI, GFCI dual purpose. You're going to use these two pole AFCI breakers whenever you're on a circuit where you're sharing the neutral, like when you have a common neutral and a multi-wire circuit. Your black and your red are your hots. One's connected to phase A, one's connected to phase B, and then they're sharing the neutral. That's when you would use a two-pole arc fault circuit interrupter. Kitchen circuits and anywhere that both AFCI and GFCI are required. Like I said, for this situation, simply install a dual purpose circuit breaker in the main panel, and that'll give you both types of protection for those kitchen countertop receptacles. Or you could install an AFCI breaker in the panel and then GFCI receptacle outlets on the countertop. Or the homeowner might already have GFI protection at the countertop and you just want to add arc fault. So you would just simply add the arc fault circuit breaker in the panel. Just remember the basic idea, the whole purpose behind this is to provide AFCI protection for the entire branch circuit and GFCI protection for anything that is plugged into the receptacle. The last item for discussion is receptacle replacements, and this is very important. If you go into somebody's old home and it has, and I mean old as old, older than me, two-prong or three-prong receptacles, and the receptacle itself was broken and has to be replaced, well, that room needs arc fault protection per the code these days. And so the code says you will put in a arc fault protected circuit. So how do we do this? Well, you can simply take out that particular receptacle and put in an AFCI device and you're done. Just wire it up to the line side, you're done. Or you could install this receptacle type upstream from your receptacle, maybe get it into the first box, and then wire up the line to the line, and then the rest of the circuit downstream would be connected to the load side. So then this will protect all, whatever, 3, 4, 5 receptacles, whatever's on that line. The third way that the code recognizes is to just simply install an AFCI combination type circuit breaker in the panel, if possible, to protect the whole circuit. So there's the three ways they recognize. But the important point is you cannot walk into a house anymore. And this is since January 1, 2014, I believe. You cannot walk into a house and just take out a two-prong receptacle and put in a new one and walk away. No. You cannot go into a house and replace a three-prong receptacle and then just replace it like for like and walk away. No. The code requires 406.4 requires that you replace the receptacle with some type of arc fault protection. And then slowly but surely, we're going to eventually replace all the old devices, or at least give it a good shot. So, like I said, the two-prong receptacles, if you're at least on the 2014, you can no longer replace that two-prong with a two-prong. Not allowed. In the past, it's been acceptable to the code to replace it with the two-prong with a three-prong, all right, as long as you put in a, that would be this GFCI type receptacle outlet. The code said you could use one of these, put this in, wire it line and load on this GFCI type and protect the downstream. As long as you put those little stickers on it, they come in the box. Please stop throwing away the instructions that come with these receptacles and switches and lights and all that. Read them, please. In there, it says that you could put on these little stickers that say, hey, there's no ground here, but this three-prong receptacle and the other ones downstream are GFCI protected. The code figures that's the lesser of two evils. So then you proceed to replace the two-prong receptacles downstream with three-prong receptacles. As long as you put the stickers on, you are meeting code. So we could do the same thing with the dual-purpose receptacle outlet replacements. All right, you have this is Legrand type receptacle, and it's got an AFCI and a GFCI, and it's got the two pilot lights there that will tell you the circuit is either on or tripped, whatever the manufacturer says in the instructions. And this also, if you want to replace that two-prong receptacle with this, now you're given the AFCI and the GFCI, and you can replace the receptacles downstream, take the two prongs out, put three prongs in, and put the sticker on there that says GFCI protected, no ground. All right, so there you have a brief explanation of the AFCI products and some of the rules. Send in any questions that you have. All right, and we'll see you next session. Van Wert out.